Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is part 1 video on the chapter of next chapter, that is cubes and cube roots, where I will discuss about what are cubes, what are perfect cubes, properties of cubes, uh, uh, how to use prime factorization method to check whether a given number is a perfect cube or not, and column method to find a cube of a number, and finally two very standard pattern of question. And all these concepts I will, as illustrative examples, I will solve problems from exercise 4A and 4B. So this video is part of the playlist CBSE Maths 8 for class 8, following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, if you are watching my videos regularly, and if my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's start the video. Okay, so I have my quick notes prepared on the left hand side. In this video, there are a couple of concepts that I will discuss. So possibly the video will go a bit longer than usual, as I will have to discuss the concepts and solve a few problems from the exercise 4A and 4B. Okay, so on the right hand side, I will do the discussion and solving, and on the left hand side, you can see. I hope you can see my notes. The fonts are big enough so that you can read it. But anyway, I will also provide the link to the to my quick notes in the description below. You can check my quick notes from that link. It will be a PDF. Okay, so let's start. So cubes. What is the cube of a number? Now, I may not be thoroughly following the notes, but I'm just keeping the notes as a reference so that I know what I have to discuss. I may not be discussing the notes line by line. Okay. So, what is a cube of a number? So, we know that cube of a number. So, if you have a number, let's say A, we have a number A. This number A could be an integer, it could be a whole number, it could be a rational number. So A. Okay, we have a number A. So then a cube of A, cube of A is nothing but, cube of the number A is nothing but A multiplied by itself 3 times. Just like we have square, A multiplied A square, cube of A is nothing but A multiplied, the number A multiplied by itself 3 times, and we know from the laws of exponents that a number multiplied by 3 times is cube of that number, that is that number raised to the power 3. So this is A3, that is A raised to the power 3 is known as the cube of the number A. So power 3 means cube, power 3 means cube, just like power 2 means square, power 3 means cube. So this is the very basic definition of cube of a number A, and obviously A should not be a 0. A is a non-zero number. It could be a rational number, integer, fraction, decimal, whatever. Okay. Now what is a perfect cube? So cube. Now what is a perfect cube? Perfect cube is a natural number. Perfect cube has to be a natural number. Perfect cube n. Perfect cube is a natural number n such that there exists another natural number, let's say m, so that we have cube of m is equal to n. Perfect cube n is equal to m cube, where we must have, where n and m are natural numbers. So for any natural number n, a natural number n is said to be a perfect cube if there exists another natural number m such that m cube is equal to n. So as now for the examples of the concept that I am discussing, you can see, refer my notes on the left hand side. So this is a perfect cube. Okay. Now cube of negative numbers. Let me quickly check if everything is visible or not. Okay. Now what is cube of a negative number? If you have a number, so let's say minus a cube, where a is a positive. Let's say a is a positive number, so definitely minus a will be a negative number. So what is cube of minus a? So this will be equal to cube of a negative number is always a negative number. This is equal to negative of the cube of the number, cube of a. You can write it like this, or this is, you can ignore the parenthesis and you can write simply negative of a cube. Cube of minus a is equal to negative of a cube. So since a, we are considering a as positive, where a, the number a is greater than 0, and my machine has already started to work very slow. I really don't know how long I can pull off this video, because I really can't write properly. I mean, I'm writing and it is not coming on the canvas. Anyway, let's see. So a is a greater than 0 positive number, so minus a will be a negative number. So minus a cube of minus a is minus of a cube. Okay, always remember that the cube of a negative number is always a negative number. Okay, so that was cube of negative numbers. Now cube of rational numbers. Cube of rational numbers. So if you have a rational number, let's say p by q is a rational number, where obviously q is not equals to 0, and p and q are integers, and q is not equal to 0. That is the basic definition of a rational number. What will be the cube of a rational number? So p by q is a rational number. Its cube is, I am raising that to the power 3. This is nothing but, this will be equal to the cube of the numerator divided by cube of the denominator. As simple as that. Okay, there is nothing fancy in this. Just like the square or any, by this comes simply from the laws of exponents. In the laws of exponents, we have studied that any rational number raised to the power m, we have already studied that if p by q is a rational number, then this rational number raised to the power some power m, where m is some integer, this is equal to the numerator raised to the power, given power, divided by the denominator raised to the power. So this is the basic concept from laws of exponents, that we are saying the cube of a rational number, p by q, is nothing but the cube of its numerator divided by the cube of its denominator. Okay. Now properties of cubes. So how many properties we have? Okay. So let for some numbers x and y, if x and y, let's say we have some x numbers x and y, such that basically x is equal to, let's say x is equal to y cube. That is x is a cube, and x is the cube of y. Now if this is the case for some numbers x and y, then if y is even, then x is even. This the point number 1, property 1, it says that if y is even, that is the y is even, then the cube of y will also be even. That is, it basically says cube of an even number is an even number. Similarly, if y is odd, then x will also be odd. So cube of an odd number is also an odd number, or odd number. Okay, so cube of an odd number is an odd number. So what is one saying? Cube of even, I mean short writing, cube of even is even. This is the basic concept. And property number 2 is saying cube of odd is odd. Okay. What is now I am not giving any examples, it will be very obvious. Now cube of an even is even. Cube of an odd is an odd. If you cube of an even. Okay, so okay, I'm not will not really try to prove how why is this so. Let that will be a little will make the video longer or complex. Anyway, just know that as a fact that cube of even number is an even number, cube of odd number is an odd number. Property 3. Now, if y is less than 0, that is, we have already seen that negative of a cube of a negative number is negative. That is precisely the point number 3 and 4. That is, if y is greater less than 0, y less than 0 means y is negative. So, if you take the cube of a negative number, the cube will also be a negative number. So, y less than 0 implies x less than 0. This basically means, point number 3 basically means that cube of negative is negative. This is basically the point. Point number 4, y greater than 0 implies x greater than 0. This is obvious. This is very obvious that cube of positive, I mean not writing the, I'm writing it very short. Cube of positive means positive number. Cube of positive is positive. And cube of negative is, cube of a negative number is a negative number. Okay. Now point number 5. This is a bit. This is a little important, but I hope you will easily understand this. That y ends with n zeros. Now, in a cube, if y is so we are having x equals to y cube. If y, the number y ends with zeros, if y end with 1 0, then definitely x will end with 3 zeros, because as you can see, so as you can see, 10 multiplied by 10, 10 cube is 10 multiplied by 10 multiplied by 10. So this is equal to, in squaring, 1 0 becomes 2 zeros. If the number ends with 1 0, its square will end with 2 zeros. So this is 100 multiplied by 10. So we are having 1000, we know. So for every 1 0 in the number y, you will have 3 zeros in the x, that is the cube of y. So that is why it says that if y, the number y ends with n number of zeros, then its cube, y cube, that is x, will end with 3n zeros, which will end with 3n zeros. So for example, so let's say if 1000 cube, now I don't, so 1000 cube, so 1000, the number 1000 is ending with 3 zeros, and the 1000 cube will end, this 1000 cube is how much? It will end, basically there will be 9 zeros. So it is ending with 3 into 3, 9 zeros. So if the number y, if it ends with n number of zeros, its cube, y cube, that is x, will end with 3n number of zeros. Okay, fine. Next is prime factorization to check a natural number to be a perfect square. Okay, so we will be given a number, natural number, and we have to check whether it is a perfect cube or not. Okay, so the concept is that we have to use prime factorization. Okay, now so what is the concept? Let's say a natural number n is given. We have to find whether the natural number n is a perfect cube or not. So there are two ways. You can verify whether a given natural number is a perfect cube or not. Both the methods will eventually use prime factorization method, but the way we will actually verify whether it's a perfect cube or not is a little bit different. A minor difference. So we first do prime factorization of n, can be expressed as triplets of equal factors. Okay, so when we will say that a natural number n is a perfect cube, if its prime factorization of the number n can be expressed as triplets of equal factors as below. Triplets mean three numbers. So as you can see, if a given number is n, if we can if we can if first we will find the prime factorization of n, and then we will we will try to form triplets of equal factors, and each equal factor will definitely be a prime factor. So prime factorization means n has been expressed as product of multiple prime numbers, and if we merge and if we express or group all the similar prime factors in triplets, that is three similar prime factors as one group, and so if all the prime factors of the given number n is part of a triplet, then the number n will be a perfect cube. Now let me see if I can. Okay, so you can see. Okay, now. Okay, so let's try to see understand this with an example. Let's say the number n is now let's say 3 is 3 into 3. So I'm not actually so I'm directly creating some random prime factorization and trying to figure it out whether it is a perfect cube or not. So I don't know what the actual number will be, because I will have to multiply all the prime factors. I'm not going to do that. So let's say after prime factorization, the number n, the prime factorization of the number n is coming out to be 3 into 3 into 3, and let's say 2 into 2 into 2, and let's say and 7. So if this is the case, what we have to do is we have to group all the similar prime factors. We will have to form triplets of equal factors. Triplets means three factors of equal factors, same factor, that is same prime factor. So this is one triplet, this is one triplet, but we can see the prime factor 7 is not part of any factor. So this implies n is not a perfect cube. Now whatever the value of n is, I don't know, I have to multiply that. That is not important. Okay, let's say if n is equal to 2 into 2, let's say 2 into 2, after prime factorization we find that n is equal to 3 into 4 into 3 into 3 into 4 into 4 and into 2. Let's say this is the prime factorization they have formed, even though the order is run very weird. Let's say this is the prime factorization of n. Now we have to form the triplets, that is triplets of equal factors. So I will start with the prime factor 2. So how many 2's are there? There are 3 2's. So I can form a triplet with all the factors of 2. So this is one triplet form, and I can also see there are there are 3 4's. So I will form a triplet of the prime factor 4, and I can also see there are 3 prime factors 3. So I will form another triplet of the prime factors 3. So I can see that the whole prime factorization of n is expressed as triplets. No prime factor is there is no prime factor which is not part of any triplet. So every prime factor is part of one or other triplet. So this will imply that n is a perfect cube. I hope the concept of forming triplets of equal factors from the prime factorization of a number n to verify whether n is a perfect cube or not is clear. Okay, so this was how do you verify whether a given natural number n is a perfect cube or not from its using the method of prime factorization. Okay, what next? Okay, now the other way, a little different way where you can see say whether the number n is a is a perfect cube or not. I will take the same examples. So let's say this example. So you have first, anyway you will have to find the prime factors of the number n. So we see that n is equal to 3 multiplied by 3, even though this is very trivial, but still I am discussing. 2 into 2 into 2 into 7. This is the prime factorization of the first example n. Now what you do is you merge all the similar prime factors as their powers. So there are primarily three different kind of prime factors. 2 in this example, 2, 3 and 7. So I will find all the product. I will merge all the prime factors of 2 as a power of 2. So there are three 2's. So this will be 2 raised to the power 3. Similarly, for 3 this will be 3 raised to the power 3, and for 7 it will be 7 raised to the power 1. Now, after doing this, if you see any prime factor, the power is not a multiple of 3, then the n is not a perfect cube. This implies this is creating a problem. This prime factor as a power 7, the power is 1, and 1 is not a multiple of 3. So n is not, this will imply this thing, that the prime factor is having a power of 1. This will imply that n is not a perfect cube. If there exists at least one such prime factor whose power is not a multiple of 3, then n will not be a perfect cube. For the second example, you can see n is equal to, let me copy paste. Okay. So the second example is this. So prime factorization is this. Okay. Now, if I combine all the similar prime factors as its power, what do we have? There are there are three 2's. So we will have 2 to the power 3 multiplied by, there are three 3's. So 3 raised to the power 3, and of course 4 raised to the power 3. So we can see that all the factors, all the separate prime factors, their powers are multiple of 3. Multiples of 3. Their powers are multiple of 3. So this implies that n is a perfect cube. This way you can also do a check whether n is a perfect cube or not. Because sometimes you might be given, you will not be given a specific number. So let's say you are given a number. So let's say you are given a number like x to the power, let's say x to the power, let's say twice m. Some powers will be given. It will not, you will not be given any specific number, but you will be given something like this: m, x to the power m multiplied by y to the power n, and let's say z to the power p, and you will be said that x, y, z are prime factors, prime numbers, and the number n is this. Then can you say whether n is a perfect cube or not? So what you have to do is that you have to check that all the m and n. Okay, so if n is this, then if you have to see whether m, if my machine is running very, if m, n and p are multiples of 3, will imply n is a perfect cube. N is a perfect cube. Else that is if at least one of these powers, either m or n or p, at least one one or more, at least one power is not a multiple of 3, then the n will not be a perfect cube. So instead of giving you a specific particular value number, you will be given this kind of problem. Is not a perfect cube. So from the powers also, you should be able to say whether a given number is a perfect cube or not. That is the powers of the prime factors. Okay. Next topic is, how do we find the cube of 2-digit number using the column method? Okay. Column method to find cube of 2-digit number. So the idea is that so 2-digit number, if x and y, let's say if x and y are the 2-digit, so let n is equal to x and y, where x is the digit at the tens place and y is the digit at the units place, then then you have to create 4 columns. Then you have to create 4 columns. You have to create 4 columns. The first one will be x cube. The second one will be 3x square y, that is 3 into x square into y. The third column, the heading, the names of the columns will be, first one will be x cube. The second column will be 3x square y, that is 3 into x square into y. The third column will be 3 into x into y square, that is 3 x y square, and the fourth column will be y cube. The name of these columns is coming from the fact that is coming from the formula a plus b x plus y whole cube. There is a formula, algebraic identity, you can say x plus y whole cube is nothing but x cube plus 3x square y plus 3x y square plus y cube. From this algebraic identity, actually the column names are coming, and the concept applied in the column method for finding the cube of a 2-digit number also is based on this x plus y whole cube formula. Anyway, so okay, so now to understand this concept of how to column method, this is very similar to x. The logic, the steps is very similar to finding the square of 2-digit number using column method. Now let me see if I can bring up the can you see the problems? Let's say if I find, so this in the textbook it is given as shortcut method of finding the cube of 2 numbers or 2-digit numbers. Can you see the problem? Okay, I can see, you can see the problem. Exercise 4b, let's do 25. Let's do 25 cube. Let's find 25 cube using the column method. So n is 25. N is 25. Definitely x is 2. X is 2. That is digit in the number 25. The digit at tens place is 2, and the digit at units place is 5. Now what do we do? So we have created the table with 4 columns, and the first column name is x cube. The name of the second column is 3x square y. The name of the third column is 3x y square. The name of the fourth column is y cube. So we have to find x cube and write its value just below the heading. What is x cube? X cube is 2 cube. X cube is, x is 2, so 2 cube, that is 8. Okay. Now 3x square y. What will be the value of 3x square y? 3 into what is x square? X is 2, so x square is 4 and y is 5. So this is equal to 12 into 5, 60. Okay. Now what is 3xy square? 3, what is x2 and what is y square? Y is 5, so y square is 25. So this will be equal to 150. This is equal to 150, and y cube is, y is 5, 5 cube is equal to 125. Okay, so you have find all the values of all the x cube, 3x square y, 3xy square and y cube. Now I will start from the fourth column, from the rightmost column, y cube. The value of the y cube is 12,125. You underline, mark the digit at the units place, that is 5. And you see that there are more digits left, that is 1 and 2. You will add 1 and 2, that is, I am double underlining the other digits apart from the units digits. This 12 has to be added with the column to the left hand side, that is 3xy square. So I will add 150, I will add 12 with 150, and the result is 2, 6 and 1. So whatever this final result is, you mark the digits at the units place, and you see there are more digits, you mark it as well, double underline. Okay, now you have to, from this column, that is 3xy square, you again have to add the 16, that is the other digits apart from the units digits. You have to add this 16 with the value of the previous column, that is 60. So I will add 16 with 60, and the result is 76. You mark in the result, you mark the units digit, and you see there is one more digit apart from the units digit. You mark it as well with double line. Now, so this is basically the concept. You are carrying forward the digits apart from the number formed by the digits apart from the units digits from the previous column to the next column, from the current column to its previous column. So I will add 7 with 8. I will add 7 with 8, and I have 15. The leftmost column, all the digits will be used. Now what will be the value of 25 cube? What will be the value of 25 cube? 25 cube will be the final value of the leftmost column, that is x cube, that is 15. Then you add the units digit of the second column, that is 6. Then you add the units digit of the third column, that is 2. And then finally we add the units digit of the fourth column, that is 5. So 25 cube is 15625, and I am really not sure whether this is correct or not, because I am prone to make mistakes. I will have to check it in a calculator. 15625 is the correct answer. Okay, I hope the steps was clear. You understood the steps, how to find, so you have to create 4 columns with x cube, x and y. X is the digit at the, so this works only for 2-digit number. A column method to find the cube of a number only works for 2-digit number, and where if you consider the 2-digit number, in that number x is the digit at the tens place, y is the digit at the units place. Then you create a table with 4 columns with the heading names. Leftmost will be x cube, the second column will be 3x square y, the third column will be 3xy square, and the fourth column will be y cube. So inside, just below the heading, you find the values of x cube, write it down. You find the value of 3x square y, write it down, and then you write the value of 3xy square, write it down, and finally the value of y cube. Now starting from the y cube, that is the fourth column, you mark the digits in the value of y cube. You mark the units digit, and you see, and if there are any more digits left, that is there are digits to the left hand side of the units digit, those digits as a number, you will have to add that number or those digits as a number to its previous column. This way you have to carry forward all the digits apart from the units digit to its to the previous column. And finally the cube will be the value of the final value of the leftmost column, that is x cube, appended by the units digit of the second column, appended by the units digit of the third column, appended by the units digit of the fourth column. Let's do another one, and then I hope it will be clear. Let's do. So this was exercise 4B, problem number 1. So I will not be doing all the problems of exercise 4A and 4B, just a few ones, so that you will get enough idea how the concepts are working or how the concept is being applied. Okay, let's do it for uh, exercise. This is also exercise for B. Let's say we are doing a problem number 4, that is n is equal to 84. We have to find 84 cube. So here x is 8 and y is 4. So I create the table. We have 4 columns. We have 4 columns. Okay. So first column is x cube. Second column is 3x square y. Third column is 3xy square. And the fourth column is y cube. Okay. Now what is x cube? X is 8. So x cube, 8 cube is how much is 8 cube? 64 multiplied by I guess 512. Okay, 512. What is 3x square y? 3 multiplied by what is x square? X is 8. So 64 multiplied by 4. This is how much? Okay. So 64 multiplied by 4 is 16, 24, 256. And this again multiplied by 3 is 18, 15 and 16, 768. 768. So these are the little time consuming calculation that you have to do. Now 3x y square. 3, what is x? 8, and what is y square? Y is 4, so y square is 16. So we have to find 16 multiplied by 24. 64, then 32. So 384. So this is equal to 384, and y cube is 4 cube, that is 64. Okay. I will start from the column y cube. I will mark the units digit, that is 4, and I will see if there are any other digits. I have 6, so I will mark that as well. Now the 6 has to be added with the value of the previous column, that is 384. So I will add 6, and the result is 10, 390. So in the in 390, I will mark the units digit, that is 0. I will see there are it has more digits. I will mark that the number. So 39 now needs to be added to the previous column. So I have to add 39 with 768. Okay, and the result is 17, 10, and 8, 807. So in 807, you mark the units digit, that is 7. You have more digits, and these more digits 80 has to be added to the previous column. So I have to add 80 to 512, and this is 590, 592. Okay, so now what will be 84 cube? The final value, the cube of 84 will be the final value of the leftmost column, that is x cube, which is 592, and then appended by the units digit of the second column, that is 7, appended by the units digit of the third column, that is 0, and finally the units digit of the last column, that is 4. So this is the value of 84 cube, and I will have to check 84 cube. 84 cube is 592704. Okay, fine. So this was a column method to find the cube of a 2-digit number. Okay. Now let me again bring the notes. I hope you can see the notes again. Okay. Notes. Next topic is okay. Okay. So now the two very standard pattern or standard variation of problems that is asked based on the prime factorization of a number to check whether it's a prime number or not. Okay. So find the least number to be multiplied with a given number n to make it perfect cube. So you will be given a number n, which obviously is not a perfect cube, and you have to find the least number that need to be multiplied with n to make it a perfect cube. Okay. So I will not, there are a few steps, there are 5 steps. So this is the one standard pattern of, very typical pattern of problem to find the least number that need to be multiplied with a given number n to make it a perfect square. And the second typical problem is find the least number to be divided with a given number n to make it a perfect square. Okay, we will understand this by solving a problem. By solving a problem. Now it will be better if I can somehow bring the both the windows. Please give me a moment, please. I'm trying to. I'm trying to bring both the. I don't think I will be able to. Let me see. No. Okay, no problem. So, oh. So let's quickly see. Let's say, let's let's do some problems from exercise 4A. Okay, let's do a problem of problem of this of the first pattern, that is can you see the problems? No. This is essential for me. Maybe, sorry friends, I'm trying to set up the two windows simultaneously. Exercise 2B. No. Okay. So let's. You are not able to see the problem statement from exercise 4A, where I will in exercise 4A I'm reading out the problem. So the problem is find the smallest number by which 1323 must be multiplied so that the product is a perfect cube. Product is a perfect cube. Okay. What was the number? 1323. 1323. Okay. Can you see the notes? No. Where is the notes? Can you see the notes now? Yes. Okay. 1323. Okay. So the problem statement. This is a problem from exercise 4A. Exercise 4A, problem number 7. The number given, the number given is 1, 3, 2, 3, and we have to find the least number that need to be multiplied with n to make it a perfect cube. Okay. So what are the steps? I hope you can see the notes. Okay. The steps. First, anyway, you have to prime factor. Now, I have an example. I have an example in the notes, so that will give you a better idea. Okay. So first, you do the prime factorization of the given number n. So I'm writing as steps, so that you can correlate with the notes. What is the first step? I have to prime factorize the given number. I have to express the given number 1323 as a product of prime factors. So let's find the prime factors of 1323. Now this is where I sometimes struggle to find the prime factors. Now will you divide by, because I am not really familiar with the playing with numbers, I really can't figure it out by which prime numbers it will be divisible. 1, 3, 2, 3. Will it be divisible by 7? 7, 7, 7, 7. 1, 6, 62, 56. Yes, it will be divisible by 7. So 1, then we have 62, 8, 56, and 9. Okay. So 9, 2, 1. Okay. Okay. So I can see, and this is 3, 7, 7, 1. Okay. So I can see even though 9 is not a prime factors, I hope you will understand. So basically what is happening, the prime factors are something like 7, 9, I can say 3 into 3 into, 3 into 3, and then we have again 3 and 7. So these are the prime factors of the number 1, 3, 2, 3. Okay. This was the first step, that is prime factorize the given number n. You just have to find the prime factors. What is step 2? What is step 2? Form triplets of equal factors like a multiplied by a multiplied by a from prime factors obtained in step 1. So in step 1 we have found the prime factors. Now we will form triplets. How? I can see there are 3 3s. So there are three, the prime factor 3 is occurring 3 times. So I am forming, this is a triplet I have formed, and I can see there are 2 7 is left. 2 7 is left. Okay. So I have formed a triplet. Only one triplet was formed. Okay. So this was step 2. What is step 3? Step 3 is saying identify all the prime factors with their powers like x to the power m that are not part of any triplet. So in this example, we are having only one triplet, and the 7 into 7 is not a part of any triplet. So I have to identify all those factors, and all those factors such that by merging the similar factors as their powers, which is not part of any triplet. So I can see 7 and 7 is not part of any 7 and 7, the factors 7 and 7 is not part of any triplet. So if I combine the 7 into 7, I can say 7 square, this 7 square is not part of any triplet. This 7 square is nothing but x to the power m in the notes. So in the notes, step 3 is saying identify all the prime factors with their powers like x to the power m that are not part of any triplet. So you identify from step 2, you identify all the prime factors which are not part of any triplet. There may be different prime factors, and some of those prime factors may occur more than once. You combine all those. In those prime factors which are not part of any triplet, you combine the similar prime factor as powers. So in this example, I can see 7, the prime factors 7 and 7, the prime factor 7 which is occurring twice is not part of any triplet. So when I am combining 7 into 7, I am having 7 square. So in this problem, I am having 7 square as so if you can correlate, if you relate, so 7 square is nothing but x to the power m. So step 3 is saying identify all the prime factors with their powers like xm. So for some number you might have more than one x to the power m. In this problem there is only one x to the power m, where x is 7 and m is 2. Okay, so we have found this. Now what is step 4 saying? Step 4 is saying for every x to the power m identified in step 3, consider the number x to the power 3 minus m that need to be multiplied with n to make it a perfect square cube. So in the step 3, you might, in this example for 1 3 2 3, we are having only 7 square. It may be possible that you will get some more numbers with powers. So for this problem we are not having any other such numbers, that is x to the power m. We are only having 7 square. So in step 4, from these x to the power m, from all the x to the power m, uh, we have to obtain the numbers x to the power 3 minus m. So for this problem, we will have 7 to the power 3 minus 2. Since there is only one x to the power m, which is 7 square, we are having the 1 x to the power 3 minus m, which is 7 to the power 3 minus 2. Okay, which is equal to actually 7. What is step 5? Step 5 is the product of every x to the power 3 minus m obtained in step 4 is the required least number to be multiplied. So, in this problem, we can say least number to be multiplied is all the numbers I obtained in step 4 is equal to, since in this problem we are having only 7, it is 7. So 7 is the least number that need to be multiplied with 1323 to make it a perfect square. Now, and the problem also says, okay, it is only asking the smallest number by which 1323 must be multiplied to make it a perfect square. Now, if you multiply 1, 3, 2, 3 with 7, the number we are getting will be obviously 3 cube multiplied by 7 cube, and this is equal to 3 multiplied by 7 whole cube. This is equal to cube of 21. Cube of 21. Okay. Let's see another one. Find the smallest number. This is again a problem from exercise 4A. This is problem number 9. This is again where the n is, the given number is 1600, and it is asking what is the smallest number by which 1600 must be divided. Oh no, sorry, let's not do divide because I have not discussed that. Let's do another example. This is my machine is running very slow, and I'm okay. So the writing experience is becoming very frustrating. So exercise 4A, let's do problem number 8, where the given number is 2560. We have to find the least number that need to be multiplied with 2560 to make it a perfect cube. To make it a perfect cube. Okay. So for the steps are, let's follow the steps. Steps. I merely cannot write. Okay. So we first have to do the prime factorization of the number, given number 2560. Okay. So let's do the prime factorization of 2560. Let's divide it by 5. So 512. Then 512, I think it's 8 cube. Let's divide it by 2. 2, 5, 6. And then again by 2, 128. And then again by 2, 64. Again by 2, 32. Again by 2, 16. 2, 8. Okay. So this is nothing but, if you do prime factorization, you will see it is 5 multiplied by how many 2's? 1, 2, 3, 4, 5, 6. We have 1, 2, 3, 4, 5, 6, and uh, for the 8 we will have 3 2's. Okay, so this is the prime factorization of 2560, where we are having 5 as the prime factor, and how many 2's? uh, 9 2's. Okay, 9 2's. Okay, so okay, now what is step 2? You form triplets of equal factors. You have to form triplets from the prime factors. You form triplets of equal factors. So definitely there will be lot of triplets of 2's. This is the first triplet of 2's. There will be the second triplet of 2's. There are total how many 2's? There are total 9 2's. So three triplets. We will have three triplets of 2's, and finally we will have the 5. So in step 2 we have formed all the triplets. Okay. What is step 3? Step 3 is identify all the prime factors with their powers, like x to the power m, that are not part of any triplet. So we can clearly see from step 2, the prime factor which is not part of any triplet is 5, and so that is nothing but 5 is nothing but 5 to the power 1. So we are having one such x to the power m, where the x is 5 and m is 1. Okay. Step 4, for every xm that we have found in step 3, we have to find the numbers x to the power 3 minus m. So I have 5 to the power 3 minus 1. In the step 3 I found 5 to the power 1. There could be many more such numbers. So for each those numbers, we have to find, for each those x to the power m found in step 3, I have to calculate or find the value, or obtain values x to the power 3 minus m. So in step 3, for this problem in step 3 we found only 5 to the power 1. So that will be in step 4, 5 to the power 3 minus 1, that is equal to 5 square. What is the final step? 5 is the product of all the x to the power 3 minus m found in step 4 will be the least number to be multiplied with given number to make it a perfect cube. So therefore, least number to be multiplied with 2560 to make it a perfect cube is 5 square, that is equal to 25. So this implies, if you do that, if you multiply 25 with the given number 2560 multiplied by the least number that we have found is 25, this actually makes the new number becomes basically, as you can see from the prime factorization, we have 2 to the power cube multiplied by 2 to the power cube multiplied by 2 to the power cube, and we have 5 and we have 20. We are multiplying it with 25. So this is becoming 2 to the power cube multiplied by 2 to the power cube multiplied by 2 to the power cube multiplied by 5 to the power cube. So these, from the laws of exponents, we can say this is equal to 2 multiplied by 2 multiplied by 2 multiplied by 5, this whole raised to the power 3. That is, this becomes a 10, 20 and 40. So this is 40 cube. So the least number after multiplying with the given number 2560 will be a cube of 40. So let's see what is cube of 40. That is 64000. 64000. And what is 2560 multiplied by 25? No, 2560 multiplied by 25 is 64000. Okay, fine. Let's do another problem. That is the second pattern of, to illustrate the second pattern of the problem. That is, let's do exercise 4. These are exercise 4A. What is the divided? Okay, exercise 4A, problem number 9. Problem number 9. The given number is 1600, and we have to find what is the least number that must be divided. What is the least number by which 600, the given number, must be divided to make it a perfect cube. So for that, we have to understand the concept. That is the steps involved in solving this kind of problem. That is the least number to be least number by which a given number must be divided to make it a perfect cube. Okay. Okay. So this time we have to find, let's say the given number is 1600, which is problem number 9 from exercise 4A. We have to find the least number that must be by which 600 must be divided to make it a perfect cube. Okay. So what are the steps? The first step is anyway to find the prime factorization of the given number. So in step 1, I will prime factorize the given number 1600. Now I can clearly see that 1600 is, I'm not really doing the prime factorization from orally. Let me try to do it. This is 16 into 100. This is equal to 4 multiplied by 4 multiplied by 4 multiplied 100 is 4 multiplied by 25. Okay. So this is now even though, so this 4 is 2 into 2, there are 3 4s. So we have, this is basically the prime factorization of the number 1600. There are 1 2 3 4 5 6 2's and 2 5's. Let me check if I did it correctly or not. 1600 is 16 multiplied by 100. 16 is 4 into 4, and 100 is 4 into 25. Okay, so we have 4 4's. Okay. So this is the prime factorization of the 1600. Now in step 2, we have to form the triplets. Step 2 is form triplets of equal factors like a into a from prime factors obtained in step 1. So the triplets will be from the 2's. We can have one triplet from the 2's. How many 2's are there? 1 2 3 4 5 6. So there will be 2 triplets of 2's. Okay, and 2 5 will remain. Okay, so this is the step 2. I form the triplets. Okay, now from step 2, I have to identify the step 3 is, from step 2 I have to identify all the so what is step 3? Identify all the prime factors with their powers like x to the power m that are not part of any triplet. So basically I have to identify all the triplets, all the prime factors that are not part of any triplet, which is this one. That is the prime factors 5 and 5, that is 5 occurring twice, is not part of any triplet. And since I have to identify all those prime factors with their powers, that is like x to the power m. So 5 into 5 is 5 square. 5 into 5 is 5 square. And for this problem, there is only one x to the power m, one such x to the power m, which is 5 square. Now you can, in the notes it is said that x to the in the step 3, identify all the prime factors with their powers like x to the power n. Here x is obviously will be a prime number, and m, it can only be either 1 or 2. Since it is not part of any triplet, this will essentially mean that m is either 1 or 2. If you give a little bit of thought, you will understand this. M cannot be 3, because otherwise it would be a part of our triplet. Okay. So in step 3 we found 5 square, that is 1 x to the power m. Now what is step 4? Step 4 is the final step. The product of all the x to the power m found in step 3 is the least number that need to be divided with a given number to make it a perfect cube. So least number uh, to be divided to to the given number 600 to make it a perfect square is equal to all the numbers, all those x to the power m found in step 3, the product of all the x to the power m found in step 3, that is, in this problem we have only one such x to the power m, which is 5 square. 5 square, which is 25. As you can see now that 1600, so if I multiply 1600 with 25, that is the least number that need to be multiplied to make it a perfect cube. So what is the number 1600 multiplied by 25? This is nothing but, from the prime factorization in step 2, we can say that this will be 2 cube multiplied by 2 cube multiplied by 5. Sorry, we are not multiplying, we will have to divide. So 600 divided by 25 is the 600 is from the step 2 prime factorization. We can see it is 2 cube multiplied by 2 cube multiplied by 5 square, and this is divided by 25. So basically we are eliminating the factor 5 square. So this is 2 cube multiplied by 2 cube. This is equal to 4 cube. This is equal to 64. 64 will be the number when 1600 is divided by the least number to make it a perfect cube. Okay, let's do another one. This is problem number 10. This is problem number 10, and the number is 8788. This is the number, and we have to find the least number by which this number need to be divided to make it a perfect cube. So the steps are, first we have to anyway do the prime factorization of the given number 8788. Now let's see, let's do it orally. Try to figure out the prime factorization orally. Will it divide by 8? Let's divide it by, let's see, let's divide it by 2. 2 multiplied by 4, and we have 3, 9 and 4. So this is equal to 2 multiplied by 2 multiplied by 2, 1, 9 and 7. Okay, 2 multiplied by 2 multiplied by 2, 1, 7. Now 2197. 9, 18, 3, no, 2197. 97. 37, 9, 19. How to find the prime factorization of 2197? 7, 3, no. 37, no. 2019. Oh, um, you divide by 19. 11, 11, 11, 10, 99. Prime factorization of 2197. 14. 7. No. 27, 27, 27. That should be 29. What is the prime factorization of 87? 8. 11. 77. 10. 99. 99. 11. 7. 77. 7. 10. 8. 9. 99. 8. 2, 2, 2, 1, 15, 7. 7, 3. 7, 9, 19, 29, 29, 107, 49, 49, 5. I'm sorry, friends, I cannot figure out what is the prime factorization of 2197. This is really, really frustrating. Let me quickly check what is. I am taking the help of internet to figure out, to find the prime factorization of. My internet is not working. Give me a second, friend. 2197. 7, 9. It is not dividing by 9. 9 to 18. 39, 30, 18, 59, 36, 37. No. Uh, 197. My net is not up yet. What is wrong? 13. Why is the net not up? Prime factorization of 2179. What was the number? 2179. 2197. So 2197. 2197. 13 into 13 into 13 into 13. Wow. Okay. So this is basically, okay, sorry friend, I took the help of internet to figure it out. What is the prime factorization of 2197? So 2197 is 13 multiplied by 13 multiplied by 13. Okay. So this is the prime factorization of the number 8788. Step two is we have to form the triplets from the prime factors. So we can see the only triplet is 13 into 13 into 13, and we are left with 2 into 2. Okay. Step 3, we have to identify all the prime factors which is not part of any triplet in the form of x to the power m. That is, all combine all the prime factors. Same. First, identify all the prime factors which is not part of any triplet. In this example, the prime factors are 2 and 2. So in all those prime factors, combine the similar prime factors as in the form of a power, that is x to the power m. So in this example, we can see 2 into 2. This is not part of any triplet, and we can see the only x to the power m identified is 2 square. 2 square. And finally, so we can say that all the numbers of the form x to the power m identified in step 3, their product will be the least number by which the given number has to be divided to make it a perfect square. So this implies the least number to be divided is 2 square, that is 4. And we can see that if the given number 8788, if we divide that number by 4, what we get? The prime factors 2 and 2 gets eliminated. We are getting 313 cube. So the given number when divided by the least number 4 gives a perfect cube, which is a cube of 13. So this was the two very typical standard problems that is normally asked, that is to find the least number that need to be multiplied or divided to a given number so that to make it a perfect cube. Now I could have solved more problems from the exercise 4A and 4B, but my machine is running very slow. I merely cannot write anything. So I will prepare a separate video where I will solve some more problems from exercise 4A and 4B as a separate video. I'm sorry I couldn't do it in this video. This video has already been longer, and I was really stuck in finding the prime factors of the number 2197. So anyway, I will end the video right here. I hope this video was beneficial, and if it is so, then please like it, share it with your friends, and also please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. The PDF of the quick notes will be in the comment section, description. You can check the PDF from there. And the next video will be of course in solving a few more problems from the exercise 4A and 4B, and after then I will move on to the next section of the chapter, that is cube roots. So until the next video, take care and bye.